you're going to attempt to go ahead and record your chapter review with voice this time. Alright, so this is your chapter 7 review. This will be part 1. We're going to have to do this in parts. Alright, I'm going to provide you with some samples or examples that will be similar to what is on your test. If you have any questions about the video or the examples prior to us doing the review in class, just see me before or after school. Alright, let's take our first example. Let's go with the cube root of negative 125. Remember, when your index is odd, then we are permitted to have a negative radicand. So we're going to go ahead and evaluate the cube root of 125. We have learned that if we take negative 5 and multiply it to itself 3 times, then we get negative 125, which is our radicand. So the answer that you would provide would be negative 5. Example 2. Let's take 16 with an exponent of 1/2. We have learned that we can change this exponential form into a radical notation where the denominator becomes your index. So we can rewrite this as the square root of 16, which is a more comfortable and familiar expression to look at. We all know that the square root of 16 is going to be 4, but don't forget, when our index is even and we're solving for equations or solving functions, we're going to add that plus or negative or positive negative in front of it. And that would be your answer, positive negative 4. Example 3. Let's take negative 125, raise it to the 2/3. Okay, so negative 125 with an exponent of 2/3. We're going to go ahead and put that into radical notation. That would be the same as the cube root of negative 125 squared. 3 is your denominator, which is your index. 2 becomes the square. We just solved a problem where we found out that the cube root of negative 125 was negative 5. What we need to do is go ahead and square that. We can't just leave that exponent off. A negative times a negative is a positive. Therefore, negative 5 squared would give us 25. Example 4. Let's do 27 with an exponent of a negative 1/3. In radical notation, well, you know what, let's not do it in radical notation, and this is the reason why. Right away we notice that my exponent is negative. When we have a negative exponent, we have to think reciprocal. Alright, we know that 27 can be written as a fraction, 27/1. Therefore, our reciprocal would be 1/27. We're going to attach the exponent without the negative sign. Now let's go ahead and take that 27 with the 1/3 exponent and write the denominator as a radical. We know 3 is your index, 27 is the radicand. 3 times itself 3 times will yield us 27. Your final answer would be 1/3, or 1/3. Example 5. Let's go ahead and multiply. 2 with an exponent of 1/3 times 3 with the exponent of 1/3. Alright, and we're going to go ahead and cube it. We notice that our exponents in this case are the same, so we can go ahead and perform the operation of multiplication with our bases. 2 times 3 is 6. Don't forget to attach the 1/3, and we are going to cube it. Properties of exponents say that we're going to take that 1/3 and we're going to multiply it to 3. 1/3 times 3 is 1, and 6 to the first is going to be equal to 6. Example 6. Let's take the 4th root of 81, x to the 4th, y to the 4th, z with an exponent of 4. Alright, one of the things I told you to look for is to see if the exponents in your radicand can be divisible or divided by the index. In this case, they can. 4 can be divided by 4 one time for each of x, y, and z. So that means I can pull out an x, a y, and a z from the radicand. What I have left is the 4th root of 81, so we need to figure out if there is a perfect 4th power. Well, we know that 3 times itself 4 times will yield us 81. So the 4th root of 81 would be equal to 3. If we take a look at our radicand, you see that we have nothing left inside. Well, we know the square root of 0 is 0, so we can just really leave that off, and your answer is just simply 3x, y, z, or 3 times x times y times z. Example 7. Let's divide. 2xy with an exponent of negative 2 over 18xy cubed. Since my operation is multiplication in between each term here, we can go ahead and start simplifying each part of our fraction. We know 2/18 is the same as 1/9. X divided by x is simply 1, but we don't need to put a 1 into our fraction here. We can just leave them off. Last, we will be left with y to the negative 2 over y cubed. Since my bases are the same, we are going to go ahead and subtract those exponents. So what we get is another fraction of 1 y to the negative 5th over 9. But don't forget what you need to do with those negative exponents. We need to do the reciprocal, or we can just simply, in this case, take y, place it in the denominator with the exponent of 5. So you would have 1 over 9y to the 5th as your final answer. Okay, we have one more example, and then we will conclude with part 1 of our review. Alright, example number 8. Let's go ahead and add 2 radicals. Let's add the square root of 24 plus the square root of 6. Right now we can't do anything because my radicals are not the same. We have no terms that are the same. Don't forget, when you don't see that index, it is a 2. That's going to tell us how to pair our like numbers. Let's go ahead and simplify know that 12 times 2 will give us 24. However, 12 is not prime, so we need to break that down. 12 can be broken down into two factors of 6 and 2. Again, we have a 6, which is not prime. Let's see if we can break it down one more time. The factors of 6 are 3 and 2. So if I look at all my factors here, I see I have nothing but prime numbers. Now I'm going to go look at my index. It's 2, so it's telling me that I need to group like numbers in pairs. If there is anything that cannot be grouped or paired up, we are simply going to multiply them together and leave them inside the radical. Alright, I'm going to pull my pairs out, which is 2. I have 6 left over that stays inside. Don't forget about the rest of our expression here, which is plus 6. Don't forget the square root. Put your equals, and now we have an equation that we need to solve. I see I have a root 6. That means I can go ahead and add 2 and the 1 that you see in front of the second root 6 here. 2 plus 1 is 3, and all we need to do is attach root 6. And this is your final answer. This concludes part 1 of our chapter review. I hope you are able to hear my voice clear enough so it would be helpful for you to follow the steps that we just performed. If you have any questions, please make sure you ask me during class